All right. Several of you have asked me about the Wheatstone bridge, so I'm going to do a quick little tutorial on Wheatstone bridges. Very simple. You don't need to do the numbers, you just need to understand kind of what happens when things change in a bridge. So on this side here we have what's called a balanced bridge. Right? Well, it's not balanced yet, but I'm about to make it balanced. Let's say I've got 2 ohms here and 2 ohms down here. And just to keep it nice and balanced, I'm going to put 2 ohms over here and 2 ohms over here. Right? Why does this make it balanced? Well, let's take a look at the voltage drops across all these resistors. First of all, I know if I just look at the left side of the bridge here, I've got 2 ohms and 2 ohms. So that makes it a total of 4 ohms across here, and 20 volts divided by 4 ohms means I have 5 amps flowing through the left side of my bridge. Now, for the purists out there, 5 amps would surely melt any sort of Wheatstone bridge, at least that we use in sensitive equipment, but it makes for easy numbers. So we'll go with 5 amps, 20 volts. Now, if we take this 5 amps across this 2 ohm resistor, we're starting at 20 volts here at this node, and then it's going to drop down. This is going to drop 10 volts, so we're down to 10 volts here. All right. Well, this same 5 amps still has to flow all the way down here, so there's another 10 volt drop. So we get all the way down to 0. Right. That's good because this is the ground. It's supposed to be at 0 volts. Let's do the same thing over here. We start at 20. There's 4 ohms, so we likewise have 5 amps, and so that drops down to 10, and that drops down to 0. Okay, so far this is a big waste of time, right? Well, let's measure across this thing. I'm going to measure something, right? We're going to put that in green because we like to measure the measured voltage, and you know, most voltmeter type of things have a red wire and a black wire. So I'm going to put my red wire there, my black wire here. So this is the negative side and this is the positive side, right, when I hook up my little voltmeter. And what will that read? 10 volts, 10 volts, and it's not going to read anything. So my V measured equals 0 volts, right? Why does it read 0 volts? It doesn't read 10 volts, it reads 0 because it's measuring the voltage difference between these two things here. So it's going to read 0 volts. All right, now let's say we actually have a sensor unbalancing the bridge. Now, if you're really into electronics, I apologize, but this is mechanical engineering terminology here. And so this orange guy down here, orange because it got hot, it could be sensing temperature, right? The resistance in this might change with temperature. It might change with strain, much like the strain gauges we use. It could be a piezoresistive pressure sensor, right? It could do a lot of things. Anyway, the resistance changes. So we have some resistance that goes up and down with some other value. All right. Well, let's go back in here and do the same kind of stuff. These are all still my 2 ohm resistors. 2 ohms there, 2 ohms there, 2 ohms there. And this one's getting hot. So let's say that one all the way up to 3 ohms. All right. How does that change things? Well, the left side of the bridge didn't change much. We can just kind of recreate what we have over here. We've got 5 amps flowing over here, and so that means this is at 20, this drops down to 10, this drops all the way down to 0, that's fine. But on this side, now we have 5 ohms over here. Right? So on this side of the bridge, we now only have 4 amps flowing there, which means that this is going to only drop 8 ohms, or 8 volts. So this drops down to 12 from 20. But here we have 4 amps, 3 ohms, so that drops 12 ohms, so it still drops down to 0. All right, still not terribly interesting, until we make some measurements. I'm going to measure my V measured here. And I'm going to set up my wires the same. I'm going to have my negative terminal black wire going over to this side. I'm going to have my positive terminal, my red wire going over to this side. And what is my V measured going to be now? Let's see. Wait a minute, this is kind of goofy. My negative side, the black side, is 2 volts higher than the positive side. So my measured voltage, V sub measured, is going to be negative 2 volts. Right? And so what I'm going to do is just, before I do my experiment, I'll calibrate this so I know for every, for every strain, for every voltage, I can correlate that with a strain. I can make some sort of a calibration curve. But all you really need to know is that when this goes up, let's see, this is going to be a relatively bigger voltage drop, so this is a relatively smaller voltage drop, so this is a relatively higher voltage. So I'll get some negative. If this one were to go up, something else would happen. If this one went up, something else would happen. So that's it. We're just trying to figure out if one resistance changes, that changes the voltage across the bridge. That's the basics of a Wheatstone bridge. And for EMA ME307, that's all you really need to know.